Howdy. Trying out a new microphone. Uh, so trying to suppress all the noise of my dog, my kids, my got the air conditioner going, got projector fan. It's getting crazy. So we're trying out RTX voice. Found a nice little way to run that off a really old graphics card, so uh we'll see if it works. We'll see if it works. But I figured since I got to do some test videos, might as well work some of this old homework, kind of get ready for the final exam. And one of the concerns that a lot of students have is they say, hey, 65 questions is too much for 2 hours. Now, typically students finish it in about 45 minutes to an hour and 15 minutes. So they usually don't even take the whole time. And some of the questions, remember, are going to be crazy easy. What is Avogadro's number? It's not going to take you 2 minutes. All right. So you're going to have roughly a little bit less than 2 minutes for each question. So let's knock some of these out while I test all this stuff out and we'll try it out. So hopefully this gets rid of all the background noise and we're able to try it. So this is right off our homework. It gave us in homework 1, gave us these temperature conversions. You'll have those on our helpful equation sheet. See if I have that printed out somewhere. So you're going to have a periodic table. On the back of it, you're going to have all our equations. Let's see. I've got a scary river picture with some notes from an older thing. Let's see what else we got. Helpful equations, part 1 and part 2. You'll want to print those out and get ready for the final. I don't have them handy right now. So that's okay. We'll be able to knock this out without all that. For the most part, it's pretty straightforward. Okay. So setting up here, this is Fahrenheit to Celsius. We're going to be using this equation. So F equals 1.8 C plus 32. I'm going to plug in the 87 for the F. 87 equals 1.8 C plus 32. Now here's where the part a lot of people mess up in their calculator. 87 minus 32. If you put that all at once, it's got to be in parentheses over 1.8. That's equal to C. It's testing time for my kids, so they took all my good calculators. Let's see if I pull one out. There we go. So 87 minus 32. I did that in one step, hit enter. All right, so one step and then I hit enter. And then I'm going to do my divide by 1.8. 30.1. I'm sorry, 30.555. So that's A. All right, so that's A. 2 sig figs. Okay, no problem. All right, the next one says go 70 degrees C to F. So I'm going to plug that in then. F equals 1.8 times 70 plus 32. And I can just type it in 1.8 exactly as we see it. 158. So my options on the next page, 158 rounded to 2 sig figs because it was 70 would be 160. All right. So always be careful about sig figs. The question will indicate or will be about sig figs if that's the difference between them, but it's clearly the only answer that's close. 19.5 Fahrenheit to Kelvin, 5 degrees Fahrenheit to Kelvin. We're going to have to use 2 equations. So 19.5 is my F, 1.8 C plus 32. So 19.5 minus 32 in parentheses divided by 1.8. That's my C. So 19.5 minus 32 divided by 1.8 minus 6.94 repeating. And that's my C. And then Kelvin is that. So I'm going to put A and S in my calculator, plus 273.15. I got 266.2, 266.2. We started with 3 sig figs, so 266 D. So D would be my answer on that. All right, see, so rocking right along. Just use those equations. Didn't take very long. All right. Now here I've got centigrams to kilograms. So it's a conversion. We're going to some old school stuff. This one is one that people miss all the time on the test. I've got metric. Remember, we want to look at the prefixes to metric. And so if I were to go over and look on the back of my periodic table, I could find my metric table. And so I can look up for there 1 cg is so many grams and 1 kg is so many grams. And so if I go look on that table, I'll find the C is 10 to the minus 2 and K is 10 to the positive 3. All right. So we're just literally pulling that up metric to metric off of this, which you can't see at all, off of this table. It's on the back of our periodic table. All right. So didn't need any extra information. We do it in 2 steps. So 341 Cg, Cg on the bottom, G on the top, G on the bottom, and Kg on the top. Ones with those, and then 10 to the minus 2 goes opposite the C, and 10 to the third goes opposite the K. So when I put this in, 341 E negative 2, not a 10E, and not a times 10, divided by E negative 3. All right, so 341 second E negative 2 divided by second E negative 3. So type that in like, whoop, all kinds of glare. Where's the glare free? Okay. And wrong button. Go. And enter. 3410. All right, now does that make sense? So let's go ahead and ask ourselves. That doesn't make any sense. Oh, do you see the problem? Right there, I used a negative when it should have been a positive. So yeah, okay. So I'm gonna just come back up. Remember to edit these. Refresher. I'm gonna come back up, highlight it, hit enter, and then I'm gonna go back and edit what I had, and we should get something small, 0.00341 kilograms. So this is wrong. It didn't make any sense. Centigrams really small, all right? Kilograms are really big. So, okay, now I look at my answers. None of them are in this format. They're all in scientific notation. So we can do one of two things. I can tell my calculator. So let's see if I can load it up here. Mold, go over to science, and then second quit. And I'm going to just hit the enter again. And it'll tell me this is 3.41 times 10 to the minus 3. And then I'm going to get back out of that. All right. Or I could have moved my, let's move the decimal place. And so let's just go 1, 2. We're going to go after the first non-zero. So that's my 3.41. We moved it 3 places. And this number is smaller than 1. Remember, 10 to the 1 is 10. 10 to the minus 1 is 0.1. So if it's negative exponent, the number is going to be less than 1. If it's a positive exponent, it's going to be more than 1. So this will be a negative 3 here. And so I come up here and look, and so that's A. Okay. So real common mistake. I did a little subtraction sign there for no reason. Maybe I would have multiplied and had the same kind of problem. Or maybe I put the 10 to the minus 2 in the wrong place. Check for a little common mistake. So exponents opposite the prefixes with this system. All right. And when you put these in, don't put the 10 in front of the E's. Okay. I'll have some of these where that's the difference between, that's probably what happened here. All right. And so, always ask yourself, does the question make sense? All right. So that was this one, real commonly missed. We got A, convert 54 centimeters to yards. So centimeters is metric, yards is English. All right. So English to English, you've got to have the ones that you know. Inches to feet, feet to yards. Centimeters is metric, so we're going to have to cross over. So I'm going to use one off my list. And the one I like is 1 inch equals 2.54 centimeters. There's actually two. You could have used We could have done this. We can go all the way up to centimeters to meters and across meters to yards. A lot of people do that. But I'm just going to do this. So I'm going to go 54 centimeters. And we'll set it up like this. Centimeters on the bottom, inches on the top. 1 inch, 2.54. Remember, this is over 1, so I'm making those cancel out. I'm going to use inches down here, and I'm going to use feet. And then I'll use feet on the bottom and yards on the bottom, on the top. So 1 yard is 3 feet, 12 inches is 1 foot. Now, not too bad, but a lot of people miss this when they put it in their calculator. So there's two ways of doing this. We can do 54 divided by 2.54 divided by 12 divided by 3. That works just fine. You could also type this in. It's 54 divided by open parentheses, and that's the key step. 2.54 times 12 times 3. All right, so 54 divided by open parentheses 2.54 times 12 times 3 is 0.59055. We started with 2 sig figs, so I'm going to expect 0.59. There it is, D. And the units on this would have been yards, and so not too bad. All right. So rocking right along, let's get to the next one. We're on problem 6 already. Pounds to kilograms. Again, metric. We starting with English. So 1 kilogram is 2.205 pounds. That's right off the back of my periodic table. I know the 2.205 goes with the pounds because everybody wants their mass in kilograms. You weigh less. All right, so 264 pounds times pounds down here, kilograms up there. 1 kilogram is 2.205. I'm just going to divide that. 264 divided by 2.205. 119.7. We started with 3 sig figs. I expect 120. Hey, that's what this decimal is here to give me 3 sig figs. All right, so B would be my answer on that. Next question is specifically on sig figs. All right, so find the first non-zero, find the last non-zero. Anything between them counts. Anything before the first non-zero. Remember, I'm not looking at the decimal place. I'm looking at the first non-zero. Doesn't count. But if there is a decimal, anything after counts. So that since there is a decimal, this counts. So 1, 2, 3, 4, 5, 6. So that's B. Okay. How many should be in this one? So the key to this problem, is it addition and subtraction, or is it multiplication and division? All right, so this is multiplication. And so I just need to know how many sig figs are in each of these parts. So, hey, my kids just walked down the hall. Here's our first good test. I bet you guys couldn't even hear them. Let's see how good RTX voice is. All right, so we had 3 digits there, 4 digits there, and we want the one that's the smallest. So my answer can only have 3 sig figs. So that's it. All right, it says, which of the following is a chemical property of sodium? All right, chemical property. That's what this question is actually about. It's which one of these is chemical property? Whether we know these or not, this is physical. This is physical. This is physical. React violently with water. That's our chemical property. So that's our only one. Okay. So the next one is a straight up definition. A blank is a pure substance that cannot be converted into a simple form of matter by any chemical reaction. Now they say chemical reaction. All right. So that doesn't include nuclear reaction. All right. So mixture, that's 2 or more. Element is 2 or more that are chemically bound. All right. That have a bond between them. And no, I'm sorry. A compound is that. An element is our answer right here. Okay, so B, that's our answer. Wow, I was reading that crazy wrong. Spacing seems crazy on this. Oh well. Hope it went this way when you had to work it, but it was online anyway. So compound, 2 or more, definite ratio. Homogeneous, 2 or more, you can't tell the parts apart. Heterogeneous, two or more, you can tell the parts apart. Element, pure substance. Cannot be converted. There we go. All right. Combination of two or more elements and a definite reproducible. All right. So definite reproducible, that's A, we said. That's our compound. And so this is our key word here. So when we do H2O, it's two hydrogens, one oxygen. All right. This number can also be written as, so, all right, I've got 3.83, and it wants us to move the decimal place 3 places, and the number that we end up with, this is a negative. Because that's a negative, we want to end up with a number smaller than 1. If I go to the right, I'll get 38. If I go to the left, I'll get 0.3, which is smaller than 1. So I'm going 1, 2, 3 places. And I'm going to have to add some zeros. And so that's my number, 0, 0. And there it is, B, 0.00383. All right. A was sneaky. Be careful. So you got to always read these carefully. So there's that one. No problem. We're already 12 in. I don't even know how long we've been going. So some of these you'll even go faster because you don't have to kind of explain them. All right. Extensive, intensive property. Okay, so let's think about those. Extensive depends on the amount. Intensive does not. So they may have some of these mixed in here. All right, so melting point does not. Boiling point does not. All right, so boiling point of water, 100 degrees Celsius, 0 degrees Celsius for the melting point. Doesn't matter how much water. The density is grams per milliliter, but it is an intensive property because the density is of water is 0.998, regardless of how much we have. The mass is just a direct measure of how much. So if it's mass or volume, that's our giveaway. So answer on this one is C. So here they have a cylinder with so much mass. And what is the density of this? Okay, so we can do this a couple of different ways. M over dV. And so they want the density as mass divided by volume. Or I can just look. They even gave us a hint here. They want this units in grams per milliliter. And so I'm going to take my 34.3 grams and divide that by 2.1 milliliters. So that's simple. 34.3 divided by 2.1, 16.3 repeating. That's B. This one, they gave me the density and they want to know the mass. So I could use this. They want to know, actually, what they want to know is the volume. So if I'm not sure on these, all right, so write down what's given 0.83 grams per milliliter, 32 grams. What they want is the volume. All right, so this is the density and this is the mass. And so we could plug them into that. We can use the definition. Density is mass divided by volume. Solve it that way. Or we can use this as a conversion factor. So I'm going to start with my 32 grams. And I want grams on the bottom, milliliters on the top. And so I want 0.83 to go with the grams and 1 up here. So I take 32 and I divide it by 0.83. 32 divided by 0.83. And I got 38.55. The best one here, closest answer would be D. So that'll work. And did I type anything in wrong? Nope. Okay. And so if I had done it this way, I would have done mass divided by density, which is exactly what we did. Excellent. Checking the answers as I go. All right. Okay, those were the conversion factors and everything we were using off of that. Okay, hang on. Let's pop up number 2. And I see already. My screen has decided to freak out on me. Give me just a second. My camera gets overloaded. Hey, see my notes. Those are the parts for amino acids. Oop. And nope, we can do better, camera. Okay, give me this. We'll examine the periodic table here. That's what we need. All right. Here's the periodic table. Periodic table. Too much light. Move this way. This is the problem. You take a real nice camera, you put it up top so everybody can see the stuff down there, and then it decides it wants to freak out. I don't know. I don't know. I guess this projector causing it to see the problems. I don't see those. So tell you what we'll do. We'll stop right here, and I'll edit these in together. Be just a minute.